Alright, so this is solutions to your revision work. Alright, so first one is about scientific notation. Now the important thing first is significant figures, and we got to remember that the zeros at the beginning of a number don't contribute to precision, so they are not actually significant. You could get them just by changing units around, right? But any non-zero digit is going to be significant, and any zeros really after these will always be significant somewhere here, just not the ones at the start. Alright, so 6 is good, 2 is good, and 3 is good as well, and so there's our 3 significant figures. Okay, but the 5 tells us that we have to round our 3 upwards, and so we're going to get 6 and 2, and then the 3 becomes a 4. Okay, now in scientific notation we always put our decimal point after the first digit, so it would be 6.24. Okay, and then to now move this decimal point back where it should go, we're going to move it back once, twice, 3 times, and 4 times, and so it becomes 6.24 times 10, and because we're moving backwards it's going to be negative, so negative 4 in the power. Okay, if we're going forwards it'd be a plus 4, or just 4. Okay, second one, calculate the value of that if x equals negative 5. There's nothing too special here, we are just going to type it into our calculator. So the important thing though is because we're substituting a negative number, it would be best to put brackets around every one of those. Okay, so we type negative 5 to the power of 4 minus 3 lots of negative 5 squared minus 7 lots of negative 5, like that. Okay, and when I do that I am getting 585. Okay, so that's my answer there. Alright. Triangle has side lengths 4, 13, and 15, and first thing we want is a semi-perimeter given by that formula. Now this time we don't really have to bracket anything because nothing's negative, it's just adding, so there's nothing too tricky to look out for. So we're just going to type in 4 plus 13 plus 15 into our calculator just like that. Okay, and so what I'm going to get from doing that, 4 plus 13 plus 15 is 16. Alright, then we have Heron's formula, which is a way to calculate the area of a triangle given the 3 side lengths. So forget that base and height stuff. No, don't do that. But this is another way, which is if we get 3 side lengths. You don't have to remember this, it's just for the sake of this question. So what we're going to do is just use the formula and type into a calculator very carefully. So a is equal to the square root of s, which is 16, we just got that, bracket 16 minus a, which is 4, and then bracket 16 minus b, which is 13, and then bracket 16 minus c, which is 15. Now, I probably won't type all of that in, okay, because some of this is easy enough for me to, I think we can do some of this easily, okay, don't be too lazy with it. So we can think of it as 16 times, that's 12, and that one would be 3, and that one would be 1. Okay, now that one I don't mind if we type in. So I think if it's easy stuff like that, it's probably good to do it without a calculator anyway, just in case you mistype something. So that's going to be 24. Okay. Alright, blood, alcohol, oops, too far. Okay, blood alcohol. So I'm going to give you the formula, but I'm not going to tell you what each of these things is, so it's important that you still remember something about this, okay? So here, N stands for number of standard drinks. Okay, I'll just say standard drinks. H stands for the number of hours. and M stands for mass. Okay, so how heavy the person is. Alright, so what are we told? We're told he weighs 70 kilos, that's our mass. Blood alcohol is 0.034, that's going to be whatever numbers that is, at 10 p.m. And he began drinking at 7:30. So first we've got to work out how many hours that is. So from 7:30 through to 10, that's a total of 2.5 hours. Okay, which means that 2.5 will be our H. Okay, and so now we can just plug in every number that we know. So the blood alcohol is 0.034, so I'll put in 0.034 here. And then, now I don't know what the number of drinks is, I'm trying to work that out, so I'll leave that as just 10N. And then 7.5 multiplied by H, which we now know is 2.5 hours, all over 6.8 times by the mass, which is 70. Okay. Now when we get equations like this, which have some tricky numbers like that, I'd probably just do all the calculations there first. Okay, just tidy up that part. So I'll write here that 0.034 is equal to 10n minus, I'll do 7.5 times 2.5, it's 18.75, over 6.8 times 70, which is 476. Okay. So now I can solve this equation. I'm trying to solve for the n. I'm trying to work out this guy. Okay, so I better clear the fraction first. So I kill the over 476 by going times 476. Do it to the right, do it to the left as well. So times 476. Let me make a barrier here just to make sure we clear. Okay, so times by 476. So on the right hand side, that's going to kill that. On the left hand side, I just got to do the numbers. So I multiply by 0.034. I'm getting 16.184. So 16.184 is equal to 10n minus 18.75. I'm still after the n, so I've got to kill the minus 18.75, and I do that by going plus 18.75. Do it to the right, do it to the left as well. So plus 18.75. On the right side, that will kill that one. On the left side, I better just add that, so plus 18.75. I get 34.934. So 34.934 on the left. On the right, only survivor is 10n. Which means the last thing I've got to do to work out what n is just to divide by 10. If I divide this by 10, I move the point back once, and so n will equal 3.4934. And the question is saying how many standard drinks is that, and I'll just say that's going to be approximately, it's about 3.5. Okay, about 3.5 standard drinks. So we'll say about 3.5 standard drinks. This formula isn't meant to be too precise anyway. And I read somewhere that nobody's seen this formula outside of our curriculum anyway, so no one knows where it came from. It's a bit weird. Anyway, that's the answer to that one, 3.5 standard drinks. Let me circle it in case some people are just reading, not watching. Alright. Solve this equation. Similar process to the one we just did. We're trying to work out what x is by doing the same thing to both sides. First thing to do though is to clear the fraction. It's all over 2, so I'm going to multiply everything I see by 2. So multiply the whole left hand side here by 2. And I better multiply the whole right side by 2 as well. I'm putting brackets around things just to make sure we're multiplying everything by 2. So on the left side, all it's going to do is kill the bottom of the fraction. and so what we're going to get is just 3x plus 8. On the right side, we're going to multiply everything by 2, so both of these get multiplied by 2. So 25 becomes 50, and minus 2x becomes minus 4x. Okay. And then to finish this off, we're just going to bring the x's to one side, so I'm going to kill the minus 4x because it's smaller. So I could do that by going plus 4x. If I do it to the right, do it to the left as well, plus 4x. So right side, that's going to kill. Left side, we get 7x plus 8 equals 50. Alright, so we kill the plus 8 now by going minus 8. And we do it left, I do it right as well. So it kills on the left. On the right side, it becomes 42. Left side, only 7x survives. And at this point, hopefully we can just see that 7 times 6 is 42, which means that x must be equal to 6. Alright, number 6. Forces experienced by an object in free fall can be described by this equation. That's gravity, that's a resistance of some sort. Alright, make k the subject of the formula. So I've got to try and isolate this k here. Okay. Now, a few approaches to this. My preferred way is to make whatever I'm looking for, try and make it positive first. See how it's like it's negative here. I don't like that very much. So my first step, you don't have to do this, but my first step would be to try and pull it to the other side so it'll be positive. So I'll plus kv squared to both sides. So do it there and do it there as well. Okay, which means it'll actually go away from that side, but it just moves to the other side. So it'll be kv squared plus the f is equal to mg. Okay, so now I still have an eye on the k here, so I'm going to kill the plus f at the end, so I better go minus f. I'm going to do it to both sides. On the left, it's going to kill that, which means that I'm going to have just kv squared surviving, and on the right I have mg minus f. And so last thing to do is to kill the multiplication by v squared. I do that by dividing by v squared. So I'll divide it by v squared, divide by v squared, and so I am left with just k is equal to mg minus f over v squared. Show your physics friends, they'll be excited. I don't know. Alright, and so that's the answer to that. Alright, finance. A $600 item is given an 18% discount, so which calculation gives the correct value for the final price of the item? So it's given an 18% discount. I would often look at this as a rectangle where it used to be 100%, but we have chopped off a bit of it. So we've chopped off this section, and this section's 18%. So what's remaining then? What's remaining must be 82% then is left over. Okay, so the final price will be 82% of what was initially there, which means it should be 600 times 0.82. That should be our answer there. Okay. Alright, so what's wrong with the rest of them? These two are nonsense really. If you minusing a flat 0.18 doesn't mean anything. Okay, then well, percentages are always taken of an amount. And C gives the discount, not the final price. That's what's wrong with C. Alright, the amount of tax I need to pay is 3572 plus an additional 32.5 cents for each dollar of taxable income over 37,000. If my income is I, which one gives the correct calculation? Alright, part A, not part A, choice A is just nonsense, doesn't do anything that we want it to. It's 3572 plus something, this is not it. This is also kind of nonsense because it's multiplying 32.5 cents by my income and then subtracting 37,000. It's a bit nonsense. Alright, so it's a choice between C and D, right? But the question assumes that my income is over 37,000. And so if I'm trying to see how much over 37,000 I've got, so for each dollar of taxable income over 37,000, that's gonna be I minus 37,000. Okay, so if I'm earning 40k, then it'll be 40k minus 37k, so it'll be 3,000, right? If I'm earning 45,000, then this would be 8,000, and so on. Okay, so that's why it'd be C. Okay, it's 3572 plus 0.325 for every, so multiplied by how much over 37,000 I am. Okay, problem with D is that this one is treating my income as lower than 37,000, which means that it wouldn't apply. Okay, this formula wouldn't apply to that. Alright, number 3. Include a GST of 25.4, which one gives the value for the total price of the item. So how this GST stuff works, again, a rectangle. Whoops, that's a terrible line. That's slightly better. Alright. Oh man, it's getting late. Okay, so pretend this blob thing is 100% again. That's the price before GST. Then we have the after GST, which means we've added on an extra 10% blob. Okay, and so now that's the final price of the item. And we're told that the included GST, which means just this GST component, just this red blob here, that is $25.4. Okay, so if just the red blob is 25.4, how much is the entire thing? Well, we've got to see how many of these red blobs fit into the blue one. Well, the red one's 10%, blue one's 100%, so that means that the blue one can hold, this one holds 10 lots of the red blob. Okay, so what color am I? The red. 10 of these guys. Okay, which means in total the full price has 11 of those, which means that the correct answer should be B. Okay, 11 of those. Okay, because that's how many of red blobs make up the whole price. Alright, I think best way to do these GST problems is to keep this rectangle thing in mind. I think that might be the easiest. Alright, investment of $12,000 earns interest at a flat rate of 5.5% per annum. What's the final amount after 3 years? So flat rate means it's 5.5% of the initial amount every single year. Okay, so after 3 years then, how much interest has been earned? Well, it's 5.5% per year at a flat rate, which means after 3 years it's going to be 5.5% multiplied by 3, which is 16.5%, or better, 0.165. Okay, so that's how much of the initial amount is being earned in interest, which means the final amount is where we think, well, if we started with 100% and we added that much, well, the final amount will have 116.5%. So it's like you're adding on 100% to that. Or we would see that this thing would become not 0.165 but 1.165. Okay, I think we've seen this sort of thing before. Increasing by a percentage is where you add on that percent to 100% and you get this decimal. Alright, which tells us that the answer should be 1.165 of what we initially had. It'd be A. Okay, and so again, what's sort of wrong with the rest of these? Well, the problem with B, I think this one multiplies the amount by the rate, by the time, so that means that this one only calculates interest. It doesn't calculate final amount. Okay. Oops, interest. And what's wrong with part C? Well, this is a compound interest style thing, okay? So that's what's wrong with this one. This one's got the wrong type of interest, okay? We're saying flat rate, which means simple interest. This one's doing compound, okay? And D is just nonsense, so don't worry about that. Okay, so the idea here is that 5.5% for 3 years means a 16.5% increase, which means multiplying by 1.165, okay, as we've done previously. Alright, number 5. This TV is purchased for 6495, depreciates by 12% per year using straight line method. So this is actually the same thing as the question we just did. It's just that instead of increasing by a flat percentage every year, we are decreasing, because that's what depreciation is. Okay, so what's the value after 4 years? Well, every year it drops. Straight line means it drops by a flat 12%. So flat 12% and per year. So after 4 years, you're going to multiply that one by 4, which means it's a 48% decrease. Okay, so again we think of starting from 100%. If we start from 100% and we do a 48% decrease, we're left with only 52% remaining. Okay, so 52% remains, which means the value of the TV after 4 years will be 52% of what was originally there, which means it's going to be that one. Okay, so again, what's wrong with these ones? Well, A is nonsense. B is promising, but B is depreciating the normal way, not straight line method, but the sort of reducing way. So this is what normal depreciation would look like, but that's not straight line. It's like the compound interest sort of thing. Okay, so I can say this one again is doing compoundy stuff. And part D, it's not part D, sorry, choice D is looking at how much value has been lost, not what the final value is. Okay, so this is about lost value, not final value. Okay, alright, Ryan earns an annual salary of $82,000. Takes 2 weeks annual leave and is paid a 17.5% leave loading. What's the gross amount he'll be paid during his leave? So first thing to do is we got to work out how much he normally gets for 2 weeks of work. Okay, annual salary of 82,000. So we remember that there's 52 weeks in a year, which means to work out his weekly salary. So his weekly pay will be 82,000 chopped into 52 bits, so divided by 52. So what's that going to be? Let me just check. It's going to be 1576.92. Okay. So for 2 weeks then, so 2 weeks will be multiplying that by 2, so 3153.85. Okay, but he's paid a 17.5% leave loading, so that means that he gets 17.5% bonus on that amount. So we need to increase this amount by 17.5%. Okay, so to increase by 17.5%, from what we just did in the previous few questions, we are going to multiply by not 17.5%, but by 1.175. Okay, so again, why the 1? Because we're increasing that 100% by something, and we're increasing by 17.5%. Okay, now if you wanted to, you could work out 17.5% of this number, then add it on afterwards, but I think we've done that calculation so much now, we should be able to see that that's equivalent to multiplying by 1.175. Okay, because we take one whole copy of it, then add on the 17.5% in one shot. So what does that equal? That equals 3705.77. Now, I haven't said anything about this yet, but if you find any mistakes in my calculations, just yeah, let me know, and I'll drop an annotation or something to fix it. Alright, so the suit is purchased for $712 after a 20% discount was given. So what's the original price? So if a 20% discount was given, what does that mean? This means that only 80% of the original price survived. Okay, so remains. Okay, which means a 712. It's like this is the final price after we took 80%, so 0.8 of whatever this original price, which I'll call P, okay, whatever that was. Okay, so to recover what this P is, I have to undo this, which means I have to divide by 0.8. So 712 divided by 0.8, which is equal to $890. Okay. Alright, so how much discount was given? Well, two ways to do that. I can either just see the difference between these two things. That might be the easiest. So 890 minus 712. So that means that $178 discount was given. That's one way. Or another way, and if you're in the exam and you've got a bit of time for whatever reason, a way to check if you're correct is you do this the other way by looking at the 20% discount and see if you get the same answer. Okay, if you get the same answer, chances are you got it right. So we can check that 890 times by 20% for the discount, so 890 times 20% is going to be equaling the same thing. Okay, so again, if your answers sort of match with each other in that way, then you can be pretty sure that you got it right. Unless you're like super unlucky. Alright, Michelle spent X dollars setting up a stall at a market and half that amount on the inflatable ducks she was selling. Calculate the percentage profit she made if she made a total of 39x over 20 in sales. Okay, it's a pretty tricky one. Okay, so we've got to first think about her total costs and then think about the profit after that. Okay, so she spent X dollars setting up the stall and half that amount, that just means X over 2 on the ducks that she was selling, which means the total cost, her total expense, was X plus an additional X over 2. So that's 1.5 X's, which I might write as 3X over 2. 1.5 is the same as 3 over 2. Okay, so that's her total cost. And we want the percentage profit she made if she made a total of 39x over 20 in sales. So her income is 39x over 20, which means her profit is how much extra she made after counting that cost. Alright, so that means the profit will be that income she made but subtracting the cost. Okay, and so it's a bit of a fraction addition now. Hopefully you still remember how to do a fraction addition. We need common denominators, don't we? So I can turn the 2 into a 20 if I multiply it by 10, and I multiply the top by 10 as well. So I get something like 39x over 20 minus 30x over 20. And that gives me 39 of them minus 30 of them, so it's going to be 9 of them, 9x over 20. Alright, so that's my profit. Now I'm not done yet because I don't just want the profit, I want the percentage profit, I want this thing. Okay, so that means I want to see, well, how big is this profit in comparison to the cost? Okay, so percentage profit is always calculated in comparison to the cost, the investment she put into it. So I want to see this 9x over 20 thing, alright, in comparison to, so normally it's as a fraction of, but I don't want fractions inside fractions, so I'm going to say it's this thing as a fraction of, so divided by the total cost, so it'll be 3x over 2. Okay, so how do we divide fractions? Well, we write the first one and we multiply and flip, so 2 over 3x, and then we see if we can simplify. So I'll take out the x on both of them. 2 goes into 20 10 times, and 3 goes into 9 3 times. So our final fraction is just going to be 3 out of 10. Okay, which means it's 30% profit. Okay, so that one I think is probably one of the trickiest things that you'll see in this whole thing. Okay, so there were a few steps there. One step was to work out the total cost, which is to just add up all the costs. So x and then x over 2, which gives you 3x over 2. Work out the total amount that she got, was given to you, 39x over 20. The profit is always how much income minus the costs. That's how much profit you make. And then we have got to do the fraction addition thing or fraction subtraction, and we get the profit. And then we think of the profit as a fraction of the initial investment, the initial cost. Okay, so we divide it by the total cost. Okay. Alright, so those are the steps in that one. Look back on that if you need to. Alright, and number 9. In 1 week, Isaac worked his regular 20 hours plus 6 hours overtime at time and a half, and 3 hours at double time. Okay, so if he was paid $857.5 in total, what is his regular weekly pay? So I think what we've got to do is just try and put this information into an equation. Okay, so he was paid $857.5 in total. So 857.5. And how I explain this in class is, if we're given these sort of final answers, we've got to think about, well, how did we get there? All right, how did we arrive at this number? The problem here is I don't know his regular rate. Okay, we don't know his normal rate. So I might just call his normal rate hourly rate. Okay, so it'll be X dollars per hour. Okay, so that means that this number must have come from working 20 normal hours, so 20x, and then 6 hours overtime at time and a half rate, so that means it'd be 6x, but at time and a half, so times 1.5, and then 3 hours at double time, so it'd be 3x, but then double time, so times by 2. Okay, so that's the overtime rates being applied here and there. Okay, we just got to tidy up the right hand side. There's a whole bunch of x's there, and I'd like to group them all into one. So I've got 20 x's, 6 times 1.5 gives me 9 x's, and 3 times 2 gives me 6 x's. So how many do I have in total? That's 15 plus 20 is 35. 35 x's. Okay, and now that all equals 857.5. So how do I get rid of times 35 now? Well, I just got to divide by 35. That's how I do that. So I divide both by 35, and I get x is equal to 857.5 divided by 35, 24.5. So that's how much he makes every hour. Okay, now the question's asking for what is his regular weekly pay. Okay, so regular weekly pay will be 20 hours, that's regular 20 hours, okay, without overtime, which means we just got to take our 24.5 that we just calculated, and we multiply that by 20. Okay, that much per hour for regular 20 hours. And so we get $490. Okay, and that's our final answer. Maybe I should put a mark on some of these to help those who are just reading this and not watching the video. Okay. Alright. Number 10. Laptop depreciates using straight line method. So that's the graph of that. What's the flat rate of depreciation per annum? Flat rate means we do want a percentage rate. Okay, so depreciation or interest is always thought of as a percentage rate. Okay, so how much per annum per year? Okay, so got to think, well, every year that passes, how much is it decreasing by? And the problem is that 1 year like that, I'm finding it a bit hard to see just exactly how much that is. So I'm trying to find a more convenient point here. So that's no good, that's no good. I don't think I really see one until the very end here. This point here, that's when it seems to actually be slightly useful to us. So what I'm going to do is I'm going to draw a line from there. Ooh, better start it from this point. Okay, draw a line from there that goes across, right? And then I'm going to draw another line that goes from here coming down. Okay. And what I'm going to find is that while this moves across by 5 years, this one, which is 300, moves up by $900 there, or rather moves down by $900. Okay, so for 5 years, I'll write this down, 5 years goes to a $900 drop. And so per annum, per year, so per 1 year, it's going to be 900 divided by 5, which is a $180 drop. Okay, so it's $180 per year, but that's not quite the flat rate. Again, we want percentage, so it's $180 per annum, but I need to think of this 180 as a percentage of the initial amount, so 1/200. Okay, so 180 divided by 1/200, I'm getting 0.15, which means it's 15% per annum. Okay, so that's my final answer there. Okay, so it's a bit like a gradient calculation. Okay, we got to see per year, per one across, how far has it dropped? How far down has it gone? Okay, and we saw the fastest, or not the fastest, but the best way to do it for this graph was to look at 5 years. It dropped $900, and I can see that very clearly, which means that 1 year you divide by 5 then. Okay, you get $180, and then you see that as a percentage of the initial amount. Alright, write down the equation of the line shown. Well, equation of a line needs two things. It's a gradient and the y-intercept. So we might just remind ourselves the equation of any line really is y equals mx plus. Now it's either b or c depending on whether you're old school or not. I'll use c because your book does. So y equals mx plus some number, and m, remember, was the gradient, and c was what we called the y-intercept, or where the line touches the vertical, the y-axis, which would be really here. Okay, so we know that this number c is actually 1200, okay, because that's where the line touches the y-axis, the vertical axis. What's the gradient? Well, the gradient was saying when you move one across, how far up are you going? But we just calculated that every time you move one across, right, or maybe up here, every time you move one across, let's do it here, you're actually moving down by, well, we calculated 1 year means it dropped by 180, so it'd be moving down by 180. Okay, so the equation of the line should be y equals, m is negative 180, so negative 180 x plus c is the y-intercept, which is 1200. Okay. Now, of course, if that's saying that that's x and that's y, if there's other letters, use the other letters. Okay, but the equation is going to be mx plus b or c, where m's the gradient, so every one across, how far up or down do you go, and the number out the end is where the line touches the y-axis. That's 1200. Okay, calculate the value of the laptop after 4 years. Now calculate, because just eyeballing it again is quite difficult. I don't know really where this is. It's somewhere between 4 and 500. Might guess it, but it might be better to use the equation here. Okay, so time in years I've called the x, it's the across. So that means that I'm going to put x equals 4 into the equation up here. Okay, so the value will be negative 180 times by 4 plus 1200. Okay, now it sort of makes sense anyway. The laptop begins at 1200, then it's dropping by 180 every year. So that means that it's 1200, then you take away 180 4 times, because 4 years. Okay, so it makes sense even if you think about it. You don't really need to just follow the equation blindly, but you know, if we have it, it's easy. Alright, so it's 480. Okay, let's circle that again. And so part D, desktop computer has a purchase value of 1000, depreciates at a flat rate of 10% per annum. Draw the graph of its value against time. So purchase value of 1000 means that the graph better start at 1000. Okay, so we'll make a note of that. So this should start at 1000 and depreciates at a flat rate of 10% per annum. Well, 10% is a percentage of the initial price, so of the 1000. So that means it's going to depreciate by 100 per year. Okay, which means that we're going to have a gradient. This is going to tell us that we're going to have a gradient of negative 100. Okay, so every 1 year across, it's going to drop by $100. Okay, I'm going to start at 1000. And knowing these two things is enough to draw our graph. So we have to start at 1000. I'll draw this one in green. Okay, we'll start at 1000. And then every year, we're going to lose $100. So say it's going to go through here, and then it's going to go through here, and so on. Okay, so we can draw a line that tries to pass through all those points. So we can do this. Alright. That might be good enough. There we go. Okay, so it's a line that goes through those things. So every one across, it's down by 100. One across, down by 100. One across, down by 100, and so on. Okay, that's our line. Green line, I'll call it. And I'll box that. Okay, write down the equation of the line drawn in part C. So we have the gradient, we have the starting point, the y-intercept, so it's again the same thing. So the gradient's negative 100, so we'll put negative 100x plus the starting point is 1000, so plus 1000. Okay, that's the equation. Okay, same deal, y equals mx plus b, gradient and starting point, y-intercept. Okay, after how many years would they be worth the same amount? Alright, same amount means what we're looking at sort of where they have equal value. That's the point over here. Now, I could, if I'm brave, I could just sort of eyeball that and try and guess what it is. But another way to think of when they'll have the same value, would be to make those two equations equal then, because that's where they're meeting. Okay, so that means that it's going to be where 1200 minus 180x equals 1000 minus 100x. Okay, so you could solve this equation, or you could just look at the graph and think, I know it's going to be after 2.5 years. Either way you want to do it, you can yeah, get the same answer, I think. So you can solve this, or you can just plug in x equals 2.5 if you're brave, and see if it works. Okay, so let's try that. Okay, let's try x equals 2.5 from looking at the graph. Okay, so left hand side would be 1200 minus 180 times 2.5, so that's 750. Right hand side is 1000 minus 100 times 2.5. It's also 750. So we got lucky and it was good. Okay, which means the final answer is going to be 2.5 years. Okay, so again, the process there was to look at the graph and see when are they worth the same value. So when do those two graphs sort of meet each other, and it looks like it's 2.5, and we confirm that by substituting 2.5 into both the equations and checking if this equal sign was true, and it was, so that means it's going to be 2.5 years. Alright, what will be the difference in value after 6 years? Well, we just got to try and work out both their values in 6 years. So let's start with the laptop. Okay, so laptop. That's the initial. That's the one that was drawn for us. That's going to be this equation here. So I'm going to put 6 years into there. So negative 180 times 6 plus 1200. So negative 180 times 6 plus 1200 gives us 120. Then the desktop is going to be this equation. So I'm going to put 6 into there. So negative 100 times 6 plus 1000. And I think that's just going to be 400. Okay, or you can even think of it as just take away 100 6 times. So it'll be 400 left. Okay, so it's these two things, which means you compare them, and the difference is where you subtract them. So it's 400 minus 120, which gives you $280 difference. So that's it there. Okay. Alright, so that's that one. Alright, number 11. David earns an annual salary of $129,380. He pays $1,500 in tax every fortnight, claims the following deductions on his income in one financial year. And given this tax table for later, I think. First one is his taxable income. Now, all these deductions on his income mean that you're going to take these values off that salary. So the answer will be to take 129,380 and subtract all of these deductions. So 590, 350, 1620. All of them going to go away. Okay, so 129,380 minus 590 minus 350 minus 1620, and I get 126,820. Okay, that's my answer. Alright, calculate tax payable. So we've got to see which bracket we fit in first. 126,820 I think is in that range there. Okay, which means the tax will be 17,542, and then plus 37 cents for each dollar. So 37 cents for each dollar over 80,000. So like we did at the multiple choice section, how much over $80,000 are we? We are 126,820 minus $80,000. That's how much over we are. Okay, so what's that going to be? 17542 plus 0.37 multiply 126 820 minus 80,000. So I'm getting 34865.4. Alright, that's my tax. Okay, he also pays a Medicare levy of 2% on his taxable income. So what's the total tax he needs to pay? So first the Medicare. That's going to be 2% of his taxable income, which is that number there. So it's 2% of 126,820. So 126,820 times 2%, which gives me 2536.4, which means his total tax will be, to add this amount, so this 2536.4 added to his income tax. So the 34865.4. So plus 2536.4 plus 34865.4. So I'm going to get 37,401.8. That's my tax. Okay, calculate whether he would receive a tax refund or whether he's got a tax debt, and find the amount received or the amount owing. Okay, so the tax that he's paid is $1,500 every fortnight. Now there's 52 weeks in a year, which means that there's 26 fortnights, so it's half of 52. So that means that he's paid $1,500, but done that 26 times, which is actually 39,000 paid. But he only needed to pay 37,401, so that means he's going to get a tax refund because he's paid too much, so he's going to get a refund. So he'll have a tax refund, and it'll be the difference. Okay, so he's paid too much already. He only needed to pay that much, so the difference will be how much he gets back. Okay, so we take away 37401.8, and we get a total of 1598.2 as a tax refund. And so that's